My name is Parashuram, and it's probably easier if you call me Ram. And I work at Facebook as a user interface engineer. A user interface engineer is pretty much a web developer, and I've been doing web development for a long time. I didn't really learn web development at college. I was mostly learning it through teaching myself from the internet. And one of my biggest ways of learning web development has pretty much been looking at the source of interesting web pages and trying to basically copy paste all the code. Also, back in the day when I was learning web development, there weren't many debugging tools that were super helpful. And one of my favorite ways of debugging web was basically this. I'm sure a lot of you can relate to how, this is how you debug web. In fact, even today, the fact that you have so many packagers and so many minifiers and so many transformers, this is probably the foolproof method of debugging or trying to understand what's actually going on in your web application. A few years ago, I started picking up React Native, and it's not a surprise that when I did React Native, my React Native debugging also involved a ton of console.logs. The reason why I'm telling you this is because my talk is sort of based on this. I am primarily a web developer with a lot of JavaScript experience, and in this talk, I'm going to be telling you my story of how I learned React Native and then started to poke around and try to learn the internals of React Native. In this talk, we'll look at what's coming up with React Native and how all of it fits together. So this is typically what my development story is. And like any story, this needs to start up like in a regular day and then get into suspense and stuff, right? So on a regular day, I was writing code, and this is what my browser looked like. I had a billion tabs open, and I knew that if I opened one more tab, my computer is probably going to catch on fire. So I did something that a lot of people don't do. I got a little bit brave, and I opened this program called Safari. Now, for people who don't remember what Safari is, it's actually a computer program that's bundled with your new Mac machines, and you open it the first time you want to download Chrome. So I was brave. I opened up Safari, and I started using Safari for debugging my React Native applications. And I wanted to print up a value of a certain variable. So of course, I turned back to my favorite console.log. And this is where the suspense part of the story comes in. I was almost going to finish typing when my boss tapped me on the shoulder, and I suddenly looked back. There was coffee on my table, and I spilled the coffee. Now, I knew how reliable my Mac's butterfly keyboard is, so I didn't want to ruin my keyboard, and I started wiping and accidentally hit the Enter key. And what I noticed was this. I was like, wait, is React Native changing my trusty console.log? That sounds weird. Now, this is not how it works on the web, right? In fact, on the web, if I was to open my console and say console.log, I would see something like this. I always thought that console.log was a native function. So what was React Native really doing? And this is where the twist in the story comes in. I got curious, and I wanted to understand what was happening. So at this point, when I was rehearsing my talk, I thought maybe I should just quit my slides and try to show you a live demo. But I mean, you know how live demos work, right? I'm probably going to come on stage and then try to open up, and then internet is not going to work. So rather than pain myself going through and trying to kill time with internet and show you how horrible I am with this game, I just thought, okay, let me not do a live demo. Let me instead record all of this and play it back to you. So that's what I'm going to be doing. So the goal here is we want to understand what console.log is doing, and that's how the whole journey started. So console.log. Let's go to GitHub and look for console.log. So there are two files here. The first file is something related to Flow. I'm not good at Flow or type systems, so I'm just kind of going to ignore it. And the second part is actually a polyfill. That seems like a good enough candidate to start investigating. So I started my investigation, trying to understand what console.log does. And if you open this file, it's a little bit small, so let me make it bigger. OK, there you go. And this looks like a really big file, so let me try to understand in this file, where does the native implementation exist? Now, at this point, because I'm on stage, I want to just take a wild guess and try to see where does that specific statement exist. So let's say we look at line number 392. It's a wild guess, and lo, there it is. So that's the function that console.log is actually using to implement it and show you React Native logs on like your console or on your Android logcat and stuff like that. So this function does a whole bunch of things, but what we are interested in is this specific call. There's a call to this function called global.native logging hook. Now, I'm pretty sure that native logging hook doesn't exist in the browser. I mean, if you don't trust me, let's check that out. There is no window.native logging, and of course, global doesn't exist in browser as far as I know. Yeah, there you go. So what exactly is native logging hook? This got me curious, and to dig further, I started thinking, hey, maybe this is something that React Native itself implements. So let's go and look at where native logging hooks exist. It exists in React Native. And there's these two files, the first one being a debug logger. The second one is where we were looking at. But there's a third file, and the only other occurrence of native logging hook is in the C++ file. Let's actually look at it and see what it does. So here's the function, and as we expected, there are two places where the string is defined, and there is something that has to do with like logging and the C++ file. Now, as I told you, I'm a web developer. I don't understand C++ much, so if in the ideal world, what I should have done is opened up a new tab, gone to Amazon, downloaded a C++ book, and then learned C++ and come back. But you know, that's not how real life works. Interestingly, I search for C++, and these are the kind of results I get. So clearly, getting started with C++ is not simple. It's about Arduino and processing and LLVM, blah, blah, blah. So I started looking at it. That didn't work out. And Amazon being Amazon, I got distracted. I started shopping for toys for my kids. And 2 hours later, I came back to this function, and the function hasn't made itself any easier. It's just as complicated as it was. And I was like, I don't know what this means. So maybe I should do what I've always been doing, pretend like I know this code, and try to figure out where it's being used. So let's do that, and let's see where the function bind native logger is used. So I continued down the journey of investigation, and I started looking at where exactly is bind native logger used. And surprisingly, it's actually used in two places. The first one is where we already saw, and then there is this iOS and an Android implementation. So that seems like the right path I am on. So just to recap here, what I'm trying to do is I'm trying to figure out how the hell is console.log working. And it looks like there is some native implementation. So let's look at the first file and look at how it's being used in the first file. So digging into it, what I see is it is indeed defined in this file, and it takes in an argument called iOS logging binder. So that's an iOS specific logging implementation. Now that makes it even more interesting because effectively I've called console.log from JavaScript, and for some reason what's happening is this goes through multiple steps and eventually reaches a .mm file or an Objective-C file. Inside the Objective-C file, I can see that the function is clearly defined, and it is actually this function that is being called when my logging happens. Now don't worry about all the path, don't worry about all the code. The point I'm trying to make is this. What just happened was, there was console.log, which somehow went a bunch of methods deep, eventually came to this file called rctlog.mm and called an Objective-C function. Now I know that contrast isn't good, so let me change the contrast a little bit. Okay, this is a little bit better, and this has been happening. Okay, like this is not entirely true. What actually happened was more like this, but let's just pretend that that whole big circle is C++. So in a way, JavaScript was invoking a native module, or a native function. Isn't that what native modules are supposed to do? Like, you know, camera, if you have to access the camera and take picture, don't you write like native modules and do RCT export and all of that functionality? Right? Yes, right? I mean, that's how native modules are. But this doesn't seem to use anything related to native modules. In fact, it doesn't even go through the bridge, does it? It doesn't. There is no asynchronous calls. It's actually one call over the other, and eventually to the end, right? So there's no bridge, there is no serialization, nothing of that sort. So what exactly is this? This is what got me curious. And I looked at, I was wondering, okay, let me maybe look at what this does. And I opened up Chrome again and looked at how old this code was. And surprisingly, this file called rctlog.mm is almost 4 years old. So things haven't changed. And I was like, wait, is React Native kidding me? Like, did they always have this idea of calling native functions without having to go through native modules? Like, is this some secret that React Native has hidden? I mean, why am I going through the trouble of writing all of these native modules and stuff when there's another secret way of calling like into native code, or if there's a secret way of calling from JavaScript to Objective-C? The answer is a little more complicated, turns out. And of course, it also turns out that ignoring that C++ class was not a great idea. So I went, and because I'm a web dev, the last time I did C++ was like a billion years ago, so I have no idea what all of this means. So I went to the other people on the React Native team who know C++ and asked them to explain to me this function. Now, before I continue, how many of you here understand or know C++? Okay, so let's take this slowly. Let me guarantee that this is not scary. It looks scary, but it is not. So let's take it one line at a time. What this function does is there is a function defined called bind native logger. If you remember, that's what we were searching for, right? There's this function, and what it does is it sets a global property on the JavaScript runtime. Let me repeat that. What it does is there's the JavaScript runtime, and on the JavaScript runtime, it sets a global property. The name of the property is native logging hook. What that means is in JavaScript, if I say global.native logging hook, it is this function that gets invoked. And what does that function do? That function is a named JavaScript function which takes two arguments and effectively takes in, the first argument is the message, the second argument is the log level, and then it logs or it calls a Objective-C function and does the translation for you and prints the logging. And finally, of course, console.log doesn't return anything, so it returns an undefined value. Now, don't bother too much if you didn't understand the code. I think it's more important to understand the intent of the code. A good example is if you go ask your local Amsterdam friend what the best bars in Amsterdam are, he's probably going to tell you how to get to the bar and about the best bar, because I've heard that people in Amsterdam are really proud of their city. Most of us just take back, hey, what the best bars are, right? What the end goal is. Just think of the end goal. It's okay if you don't understand the code. So this is what happens, and this was something new. This is what is called JSI, or JavaScript interface. JavaScript interface is this new and standardized way to expose native objects, like expose Java objects or Objective-C objects from your native modules to the JavaScript world. Effectively what happens is just to summarize, we had global.native logging hook, which was called by console.log, and this eventually calls an Objective-C Objective-C functions from JavaScript to Objective-C. Now that we know something like this exists, how about we extend this idea not just to console.log, but to all of our native modules? Like, let's say we have a camera module, or let's say we have a sample module. How about we have a sample module and a function called add1, which is implemented on the Objective-C side, or let's, for example, take Java just for a change. So what if it's implemented like this in Java? Effectively, it's a single Java class. It takes in a single function. The function is called add1. It takes in an argument, which is a number, and then returns a number by adding 1 to it. That's what it is. Now, if we had to write this in a similar fashion like console.log, what would that look like? Well, we are going to have different files, one in JS, one in Java. And then let's expand this JSI box. Of course, if you remember, like last time, we have to set a property on global, right? I mean, console was set on global. So let's set a property on global. And in this case, let's set that property to not be a function, but to be a class. Because obviously, you don't want sample module to be a function. Sample module should be like a class, and that should have a function called add1. So let's set a sample module, and what does sample module look like? A sample module needs to inherit from this special JSI object called a host object. Now, the interesting thing about the host object is host object effectively says, hey, though I'm written in C++, I'm going to be exposed to JavaScript. And it needs to implement one method called the get method, and this getter is very similar to a JavaScript getter. You know, when you say sample module.add1, if you had a JavaScript getter, that JavaScript getter gets executed, right? This is pretty much similar to that. What that does is you get the method name, or you get the property on which you're accessing it. And then if you say, hey, if I'm trying to access add one, we will return a function that calls Java's JNI. Now, I think I've written more than 240 characters of C++ for one day, so I'm not going to write any more C++ code. But the red comment there basically says, that's the place where you connect your JavaScript to your Java or to your Objective-C code. So effectively, what we have done right now is we've taken a statement in JavaScript, converted it, and plugged it in or wired it in all the way to Java. Well, this, my friends, is pretty much what is called TurboModules. In fact, you can actually generalize this. For example, instead of setting a global variable for every single native module, you can just set a getter, and instead of having to set, say, for example, a property every time, you can make it generic enough. This whole process of making this call generic, that's what is called TurboModules. And then you see the C++ at the top. You don't have to write this by hand every single time. The pattern is very similar. So if you have a native module 1 versus a native module 2, you just have to list down all the methods that it has and then write the implementation. So all of this can actually be code generated. And that is the other part of the new architecture of React Native, which is called code gen. So effectively what you'll have is you'll generate a file called samplemodule.cpp, which links samplemodule.js to samplemodule.java. In a nutshell, this is how the new TurboModule system works. Also, there are some questions that a lot of people ask. For example, what about existing JavaScript code with this new system? If you noticed, most of the changes were actually in native code, right? So existing JavaScript would not have to change as much. Similarly, if you're writing view managers or if you're writing native modules, you just have to write that C++ layer. So you can always come back with a backward compatibility layer, and I'm actually hoping that someone in the community is able to write that. Similarly, if you notice the code gen that I showed you, the code gen happens via the flow type definition that I had. So you know in flow I said, hey, my object is called sample1 and it has these 10 methods. It happens through flow by default for us right now. But there's no reason to use flow. We actually have a system where flow generates JSON, and that JSON can generate C++. So if you're using TypeScript or if you're not using any type system, you don't have to use the same code gen system. You can actually write your own as long as your methods and your object shape is defined in some sort of JSON. And this is actually even better because with a JSON structure like this, with such good type safety, you'll actually be able to transfer all your type safe information from native code to your JavaScript code. So you know if you do code push, for example, you might end up in a state where JavaScript calls a method that the native code may not have. With this system, that actually can be taken care of. What about C++ modules? A lot of people don't know this, but React Native actually lets you write native modules not just in Objective-C and Java, but also in C++. In fact, this system is even better for C++ because now you don't have to go through the Java layer at all. What about performance? Like, are we doing all of this for performance? The answer is sort of yes and no. I mean, if you remember, we used to have a bridge. The bridge used to be asynchronous, and hence it used to be non-blocking. And as a result, it was super simple to like call, and no one was waiting for methods, right? What about that? Like, where does all of that go? So the good thing here is, if it's asynchronous, converting it to synchronous is hard. You have to write your own custom logic to block it and stuff. On the other hand, in this case, the calls are synchronous, which means Java or Objective-C can now return a promise. And it'll be up to the native module to decide whether it wants to return immediately or whether it wants to return later. And in fact, in this case, serialization is easy because what you get is you get a return back to a C++ pointer with methods on it. You don't have to worry about serializing it, deserializing it. You can just call methods on it. It's as if you just had a JavaScript object that you got back. And then finally, the biggest question of it all, can I use it today? The reality is, most of this code actually exists in open source. It's not super compilable right now, but if you're curious to understand what actually happens, and in fact, if you're actually interested in contributing back, look at this folder called React Commons/TurboModules/core. That's actually a pretty good place to get started, trying to get your head around how does this new system look like. Okay, so that's what the system is. But then again, the third question, does it have to stop at native modules? Not really. Why can't this be a view that is written in native, and why can't this whole system work with views? Turns out it can. It's just that there's a little bit more nuance to it, so I'm going to go into details of how the whole view system and the UI system works today, and then talk about how it can be converted to the new system. So today what happens is when you start a React Native application, you have this class called app registry, and you say app registry.register application, right? What happens is when your app starts up, your app registry calls a function that you registered, which eventually calls a JavaScript function called run application, which then calls your native components and then does the rendering and all of that. And this eventually this React talks to the UI manager. And whenever someone says React reconciler, right, this is where the React reconciliation happens. And what React talks to the UI manager is things like, hey, go create a view for me, or go append a child. You know, the tree diffing stuff, that's what this happens. Turns out that all of these functions can actually use JSI. They don't really have to go through the bridge, which also means all of this can be synchronous. What that means is all of the operations that you have regarding like creating a shadow node or creating a view or adding it to the view, that can actually be synchronous. In fact, this is called Fabric. Fabric is the new architecture, or is the new UI system in React Native. And if you want to look at Fabric, we can open up Chrome again. And this is what Fabric looks like. And this is the JavaScript. So what you see is all of these commands here. And all of these commands are just JSI commands exposed to JavaScript. So in the future, React Native doesn't have to go through the bridge, call the UI manager and create new stuff. All it needs to do is directly call these functions as if they were exposed to JavaScript right away. This is even better for performance. So for example, let's take this property called set native props. A lot of us use this for animations, right? Now the problem with animation, we say is animation is slow because it's asynchronous and stuff. What if set native props was actually a direct function call? In that case, what will happen effectively is all of this will be called immediately, which will make your animations much faster. In fact, you can have the exact same code gen system, and every new view manager that you have can be code generated with the properties, with the props that the view manager exposes. In the new system, what that would look like is at the top there, you'd basically get the app registry module, you'll get the run application, and then you'll just call it. Like you'll call it as if you're calling a JavaScript function. And this would again be synchronous. So what does this all mean? Fabric basically enables this idea of a React surface. The idea basically is, today the render function is asynchronous. Today what happens is when you start up React Native and you call render, it does its stuff, it opens up the function, then asynchronously starts adding views to it. It doesn't have to be that. This can be synchronous. What this will also enable is on things like recycler view or UI collection, where you want to render items synchronously, this is going to make that possible. It'll also help animations a lot, because now, remember that you'll be in a world where if your animation is actually defined in JavaScript, native interpolators can call into JavaScript through this method that I showed you. And that way, JS can also call back into native to do things like cancellation and stuff. So you may not have to worry about declaratively telling React Native what your animations are. So to summarize, I know this was a little, this was a lot of code. So to summarize, here's what we saw in this talk. We spoke about JavaScript interface, which is a way for JavaScript to communicate with native code, native Java or Objective-C code. We spoke about Fabric. Fabric is the new UI manager or UI layer in React Native. We spoke about TurboModules. TurboModules is the new way of calling native modules in React Native. And finally, we have all of this tied together using CodeGen. And whenever someone says the new architecture of React Native, this is probably what they're talking about. There's some more resources about what these are. The first one is a talk at React conference about the new architecture. In this talk, I mostly spoke about how things are done. I showed you code and talked about like, hey, this is how the end-to-end calls happen. But if you're curious about why do we need this entire system, why do we need this whole new system, I would highly recommend going and taking a look at the React conference video about the React Native new architecture. Similarly, a lot of CodeGen is already starting to work, and we definitely need community help there. So I would recommend Eli's React Native CodeGen deep dive. This was mostly an internal talk that Eli gave to Rick, and then we decided that because it's going to be useful for the community also, we recorded it and published it. So this is actually something that is also super useful to look at. And finally, if you want to follow along and try to understand where we are at with all of these things, there's a repository on GitHub called, there's an organization on GitHub called React Native Community. In there is a repository called Discussions and Proposals. go into the issues, and inside the issues, these are the 4 issues that you may want to follow. On these issues, we have like regular updates. We answer questions from the community. People in the community are actually starting to help. In fact, I think recently, Eric Lewis helped us compile Fabric for iOS, Fabric on the iOS system. So we actually need help from the community, bringing all of this to the community. And if you're interested in using it, it's actually a pretty good place to start. Again, my name is Parashuram. This is my Twitter handle. Hit me up with any questions. I'll be more than happy to help you folks grok this entire system. But that's all I had for my talk. Thanks for being such a good audience.